Hello students, so today we are going to discuss ideal Atwood machine. So what is ideal Atwood machine? It is basically arrangement of two mass and one string system which passes through a massless pulley. So there are two main characteristics about an ideal Atwood machine. The first thing is the pulley should be massless, and second characteristic is that the string should be massless and inextensible. So these are the conditions for it being an ideal Atwood machine. If any of these conditions fails, then it will not be an ideal Atwood machine. So how do we solve such kind of problems where mass pulley systems are present? The first step before solving these type of problems is to draw the free body diagram of the masses present here. So we will draw the free body diagram for the two mass bodies here. So let's draw the free body diagram for mass m1 and m2 here. So for mass m1, what are the forces acting on this? Is m1g, that is the weight of the mass acting downward, and tension force acting upward through the string. Okay, so free body diagram is basically the representation of all real forces acting on a body. So this was the free body diagram of first mass m1 because no other force is present on it. And similarly we can draw the free body diagram of mass m2. So for that it will be vertically downward force weight acting on it, m2g, and tension force acting upward, that will be T. So of course if it is given that mass m1 is greater than m2, then the weight m1 will come downward and m2 will go upward. And suppose m1 is coming downward with acceleration a, then definitely m2 will also go up with an acceleration a if the string doesn't slacks. So but the acceleration magnitudes will be equal, not their directions. So you won't say that accelerations are same, you can just say that acceleration magnitudes are same. So after this, so under the effect of forces, the mass m1 is coming downward with acceleration a. This is coming downward with acceleration a, and it is going upward with acceleration a. So now we will write Newton's second law of motion for the two bodies. What is Newton's second law of motion? That says the net force acting on a body is equal to its mass times acceleration. What is the net force on the first body? It is going downward, so net force is downward. So net downward force will be m1g minus upward force is T, that is equal to mass times acceleration. This is first equation. Similarly for the second mass, you will write net force upward in direction because it is moving upward. So net upward force will be T minus m2g is equal to m2 times acceleration. This is our equation 2. Now what we can do to solve here we have two variables T and A. Other values are given m1, m2. So we can add these two equations. Then minus T and plus T will get cancelled, and you will be left with m1 minus m2 and g common on the left hand side, and on the right hand side it will be m1 plus m2 and a common. And from here you can write that a is equal to m1 minus m2 divided by m1 plus m2 times g. So this is the expression for acceleration that we had to find out. Okay, so now next thing is to find the tension force. Now we can put this value of acceleration in any of the equation, putting value of a in equation 1. So if you put value of a in equation 1, what you will get? m1g minus T is equal to m1 times this value of a, which is m1 minus m2 upon m1 plus m2 into g. And from here we can write T is equal to m1g, and minus this whole right hand term will come on the left hand side. So you can take m1g common in both of them, and it will be 1 minus m1 minus m2 upon m1 plus m2. And if you can simplify it, then it will be m1 plus m2, the LCM, and in numerator you will have m1 plus m2 minus m1 plus m2, and you can see that m1 and m1 will get cancelled, and the remaining term will be m2 plus m2 is 2m2, and in numerator m1g will be multiplied, so it will become 2m1 m2 times g. I write g here, and in denominator it will be m1 plus m2. So this is the expression for tension force which we had to find out. Okay, so yeah, that's all about an ideal Atwood machine I wanted to discuss with you. So next time we will again meet with some interesting problem. Till then, take care. Bye bye. Thank you very much.